which model is correct. In Christopher Hardaker's new book, The First American, he cites a letter that Williams wrote to Armenta in 1989. In this letter, she explains the impossible dates found at Hueyatlico by proposing that an unconformity accounted for the extreme age of the artifacts.
So it became very obvious the thing that had to be done is to go back and dig it again. But this time, at the site, as the dig was being conducted, the professionals that were needed to analyze all these notions, and especially this idea of the undercutting of the stream.
Well, it's June 15th. Bob McKinney came. He's in the blue shirt.
Bob McKinney received his degree in geology from MIT and has been working with oil and mining companies for the past 40 years. Bob examined the monoliths taken from Hueyatlico by Roald Fryxell in the mid-60s. He compares them with rock samples he has taken from the field to determine if the Hueyatlico ash overlays the beds the artifacts were found in.
This is as if you were to take that whole trench and bring it home with you, but you can't do that. So you take one slice out of the wall of the trench, glue it to a board, and bring that back so you can study it just as it was in the outcrop.
You can see the location of some features which we called monoliths, which Fryxell collected as stabilized columns of sediment in their original position. And these were spaced in such a way so that they overlapped stratigraphically, going from one down to a next step, down to another step, down to another step. And this was done all the way down into the area where Irwin Williams had done her digging.
You can just loosen it up and take it off.
The idea behind looking at this particular section, the top end of this is down here, the bottom end is down there. The top end is actually in the tephra. Here's a sample of that rock, and this is the tephra. This is the volcanic ash that has been dated radiometrically. And the idea here is to take a look at this continuing section, which has not been reassembled or anything. This is just exactly the way it was when it was pulled out of the side of that trench. So we have this length of stabilized section taken from a trench located about 20 to 25 feet from where the fossil remains were found in this particular kind of rock. There is no question in my mind from a geological point of view that the zone that contains the artifacts was not incised by a more recent stream. And to do this, to prove it to ourselves, we have traced that zone from underneath the overlying tuff bed, which is a very good identifying marker, all the way back around the front of the area that's being benched right now, up to a trench that goes back underneath it, and we've followed this bed the entire way, and it is not interrupted, not incised by anything. Therefore, the strata that contain the bifacial tools and together with the bones has not been disturbed at all. The important point here is that the section that we examine is the section in which the fossils were found. It was not eroded, it was not redeposited. Those samples are right, those tools and everything else are right where they started.
The monoliths Fryxell removed and preserved turned out to be valuable assets to the investigation. According to Bob McKinney's analysis, they proved that the artifacts found by Irwin Williams were in strata beneath the Hueyatlico ash. However, Mike Waters found evidence to the contrary.
So what we did is we excavated a trench, my Mexican colleagues and myself, which would expose this area right in here, which would be one wall of Cynthia Irwin Williams's excavations. And then in addition to that, we excavated another trench going this direction to find again the other side wall of our excavations, and we did find the end of our excavations, which had been taking place out in this region right here. And then we extended that trench up the hill to where it intersected and came into contact with the Hueyatlaco ash. This way we could then examine the layering, which we call stratigraphy, from the Hueyatlaco ash all the way down through the profile in this trench and out into Cynthia's excavation area. And therefore we could see if any of the units went underneath the Hueyatlaco ash or were unconformable against the Hueyatlaco ash and therefore younger. The cross-section that we'll take a look at now is this wall right here, and it extends from her excavation area, you know, and then up here to where the Hueyatlaco ash is located. What you're looking at is this would be Cynthia Irwin Williams's one of her excavation walls right here. And what we did when we did the mapping here is, like any stratigraphic project at any archaeological site or anywhere, is you just objectively define the units. You use textural analysis, cementation, the bedding structures, you know, the undulatory topography, the cross-cutting relationships of units to define different stratigraphic units or define the layering within the sequence. And when we did this, we were able to come up with this sequence showing, you know, the Hueyatlaco ash here, and then underneath the Hueyatlaco ash was a very thick section of floodplain sediments, old riverine deposits. It was a vertisol, which is, you know, vertisol is a clay that expands when it's wet and contracts when it's dry. And then underneath that were more fluvial sands. Okay, were probably channel and bar type sediments. And those channel sands extended all the way out into her excavation area. And then erosionally on top of that, there must have been a period of erosion at some time because those sands were truncated, and you can see old channels like this, and then a channel comes down here, and this channel actually was multiple channel fills in it with gravels, you know, cutting into the top of Bed I. Then it came up like this and actually truncated the older stratigraphic units, including the vertisol. So what you would have had at this site, you would have had fluvial deposition, which is riverine type deposition, when all these sands were laid down. Then there was floodplain deposition here, in which you had the vertisol formed. The Hueyatlaco ash got on the top of that. Okay, it was deposited as airfall ash. And above that, there's some additional sediments, but they weren't mapped in because we only took our section to the Hueyatlaco ash. And then sometime after that, there was an erosional event, you know, again, a fluvial event where a channel cut down and truncated, you know, all the older deposits, and then new channel sediments were deposited, okay? Now, in correlation with what Irwin Williams found back in the 1960s, once this cross-section was made, we got out her old cross-sections that she did back in the 1960s, because we wanted to find out, okay, of the units that we defined, can we identify Bed I, where she claimed she found the unifacial artifacts, you know, and can we find Beds C and E, where she found the bifacial material? And, you know, fortunately, we had several places where her cross-sections, which would actually be coming this direction, cross-cut, you know, our profile. And when we did this, we were able to identify that this was more than likely what she called Bed I. And this is, again, where she claimed to get the unifacial artifacts from. And Bed I comes like this, okay, and extends across in this direction, pinches out in this direction, just like many geological units do. But it's also overlain by kind of a silty sand deposit, which then is overlain by this vertisol, which is also overlain by the Hueyatlaco ash. So very clearly on stratigraphic grounds, we can say that Bed I is definitely underneath the Hueyatlaco ash. But one thing that we did discover, and it was, you know, pointed out by Cynthia Irwin Williams, was that there was an erosional contact which separated what she called the unifacial material from the bifacial material, okay, as she reported it. And we very clearly found that erosional contact, just like she had reported, and that erosional contact comes up in this direction, you know, and cross-cuts and cuts across the older vertisol, indicating that this is a much younger unit, unrelated and younger than the Hueyatlaco ash. Now, the interpretation of the geology that was made in 1973 by Malde and Fryxell and Virginia Steen McIntyre, we've confirmed part of that stratigraphy and then are at odds with other parts of that stratigraphy. And the part that we confirmed was the fact that bed I does indeed go underneath the Hueyatlaco ash. But where we differ is that they believe that these deposits, which would be the equivalent of Irwin-Williams's units C and E, also went underneath the Hueyatlaco ash. And they didn't recognize this erosional contact. Instead, what they saw and they felt was that the geological deposits came this direction and then kind of disappeared into this vertisol. But the work I did, indicated that very clearly there was an erosional contact separating this from that, and that this unit containing the bifacial material had to be younger.
Waters looks at this contact here at the base of the channel and extends it up into thin air and makes it unconformable against the higher deposits, including the Hueyatlaco ash and the higher units. There's no physical basis that can demonstrate that these deposits lie against or on the Hueyatlaco ash. That information doesn't exist because it's been lost by erosion, if it ever did exist. What does exist, however, is physical evidence that is still preserved. And later on I will show some photographs which show how these channel deposits, 2 meters thick, were topped out or capped out by subsequent material which accumulated first on the stream bank here as in an area which I call a levee, and which spilled to the south as finer and finer material in a floodplain, which makes the levee and the floodplain continuous as the latest member of the channel fill here, and also places all of this material below the Hueyatlaco ash, the overlying clay, the Tillip Round mud, and the Buena Vista lapilli. In other words, we see here a simple stratigraphic sequence from Unit I, the sterile material that overlies Unit I, a channel only a couple of meters deep, cut down into those deposits, capped off with overbank material during flooding of the stream, forming a levee and a floodplain, subsequently filled the area, then accumulating more clay, the Hueyatlaco ash, more clay in the higher deposits. The reality of this can be seen because it's still in the ground. This is what we exposed in 1973 and preserved by backfilling the trench.
If you look at the photographs here, you can clearly see this erosional contact. This is to be the vertisol right in here, and you can see the contact coming down here, cross-cutting and cutting the vertisol and coming down that way. This is just a better photograph of this, showing the structure that's in that floodplain vertisol, but you can clearly see the erosional contact coming up like this. And that contact is this contact you see right here. Okay, and then it kind of comes on down that direction. But anytime you have a situation where you have something like you're following a contact like this and you've got clay, and then you cross an abrupt contact like this, it's almost vertical or very high angle, and then you go into something that's completely texturally different like a sand, it's telling you that something has happened here. And geologically, you have to evaluate this to determine whether you have an erosional contact there separating them, meaning this is older and this is younger, or is there some sort of relationship here where this is grading into that? And as I say, in '73 they thought this was grading into that, but I think you can very clearly see in this photo that this is a very sharp contact with clay on this side and sands on that side, and that this contact comes up in here or it's been disturbed by vegetation. But very clearly this is younger than that. I think the reason that that might have happened is even when I was out there, I noticed that that part of the section in the vertisol tended to dry out a lot quicker. And when it dried out, it obtained kind of a whitish color, you know, similar to the sands. And so as you come up here, you can kind of see that same contact I was mapping in the erosional contact. And then in '73, what they did is they went with the color, I think, and came across this way and mapped the sands grading into the clays there. But in reality, if you look at this photo, I think you can see the contact, and the contact comes up like this. And what you see in here is a drying phenomenon. You can still trace, if you look closely at this photograph, the structure of the vertisol coming in this direction and coming up this way. But then when you look at this part, which are the sands, you can't see any of that soil structure. So I think even in the '73 photo, you can pick up that same contact coming up just like this between the pure sands and the clays.
This is a photograph made by Roald Fryxell in 1973. It is a place where Mike Waters, in an interview that he gave a couple of years ago, discussed what he calls a drying phenomenon. He was beset because of the location of his unconformity going up to the ground surface with dealing with the similar degree of coloration or lightness, if you will, of the area across where he drew his unconformity. As I understand it, he would draw the unconformity from this contact and he would take it up to the ground surface. That's the way he kind of pointed it out in his interview on video. And so he was had the problem of dealing with this material in here being fairly light and this material over here being fairly light, although he wanted to make the deposits on the two areas stratigraphically different, making this an older area, making this a younger area in his channel. So he came up with the expression drying phenomena. And as I understand what he's driving at is that in order to account for the similar degree of lightness, he said that this area here, which he thought was older, had dried out in the same way that the material here had. And therefore, there was, in his view, a spurious continuity across what he took to be a contact, a spurious continuity between material here, which he thought was young, and material over here, which he thought was old. Now, our interpretation, of course, is entirely different. We see it not in terms of continuity of color, but in continuity of bedding. And that's why it's important to recognize that Fryxell, in order to bring out that bedding, scribed the bedding planes going from this area down to here. And therefore, we see this as a continuous layer, although changing in texture from sand to clay.
Another thing is when I examined this contact in detail, because I knew there was going to be some concern about and controversy over this contact, is that in the lower portions of the vertisol here, you know, there were small little shallow channels of very fine sand. There were some sandy clay deposits in here. There were some pure clay deposits. There were some sandy, silty clay deposits that had accumulated within a very small little channel here. And each one of those deposits, the clay could be traced over here, where you again had clay along this contact on that side of the contact and sands on this side. And again, you had clay on this side and sand on that side of the contact. And so this area would tend to dry out a little quicker than the rest of it, this being pure clays, this having some sand in it. And so it would have led to that idea that this unit actually extended off underneath the vertisol. But very clearly, I think you can say there's a clear separation, erosional contact between the units that contain the bifacial material and the other units that supposedly contain the unifacial material.
Classically, a vertisol is characteristic of a climate which has strong periods of wetness and strong periods of dryness. And of course it has to form in a clay, and it's a soil property. It starts from the ground surface, works its way downward, and the mechanism is alternating swelling and contraction of the clay under the influence of being wet and dry. And a result is that a vertisol has very strong vertical mixing, and which obliterates all signs of bedding. But note that there is this bed over here, light colored. It starts on somewhat higher ground, dips to the south, kind of flattens out, just as the Levy model says it should. And this light colored layer is a bed. But here's another bedding feature in what Mike would call a vertisol, and therefore an area in which all bedding should be obliterated by the vertical mixing, which is characteristic of vertisol.
In summary, you know, bed I would go underneath the Weyat-Laco ash and therefore be older than the Weyat-Laco ash. How much older? I don't know. Probably not that much older, because this sediment package could accumulate very quickly. But this erosional contact indicates very clearly that this postdates all these other older fluvial deposits as well as the Weyat-Laco ash. And so therefore this is younger than the Weyat-Laco ash, the units what she called bed C and E that contain the bifacial artifacts.
Despite the conflicting theories about the relationship between the Weyat-Laco ash and the unconformities, both parties agree that the Weyat-Laco ash overlays bed I. The question now remains, were the unifacial artifacts reported by Cynthia Irwin-Williams actually found in bed I?
If artifacts were found in bed I, and it's very clear that bed I goes underneath the Weyat-Laco ash, then are we dealing with artifacts that are, you know, over 1 million years old? And I think the answer to that question is no. And because some of those artifacts are more sophisticated than what you see even in the old world. We were able to find all of Irwin-Williams's excavation records, or a large number of her excavation records. And so we took each one of her excavation lines and began plotting various ways that she identified, you know, beds E and F and G and I and all the other layers that she defined. And in one set of notes, we found that they would contradict with other sets of notes, and then notes written on artifact drawings would indicate that it came from bed I, but then you go back to the records and it came from bed G, but then you see she scratched out bed G and changed it to bed I. So there seemed to be a lot of jockeying going on as to where these artifacts came from. And one thing that we noticed is that when you put these things onto a spreadsheet here, is that many of the artifacts that were found, and there weren't that many found within bed I, were found right on the contact of this unconformity. So in other words, you might have bed I right underneath the unconformity, and there might be an artifact and it might just be a slight distance, you know, no more than 10 centimeters below the unconformity.
So you're saying most of the recovered artifacts were close to the unconformity?
Right, and so I think maybe what had happened is when, you know, this is a very geologically complex area with a lot of cutting and channel cutting and filling, and it's hard enough to see when you're looking at it in cross section, but imagine you're an archaeological excavator and you're coming down on it horizontally, you probably wouldn't pick up on all these subtle unconformities because they're fine-grained sands on fine-grained sands that are cutting in and out. And so any kind of unconformity would have been recognized after the fact. And it's also kind of interesting that some of the artifacts that are attributed to bed I, like this one here is directly underneath bed E, but then this one that also came from, quote, bed I here, was once assigned to bed E and then to bed G and then eventually down to bed I. So she kept changing her nomenclature
going
throughout.
deeper into section as she went.
Yeah, or just actually, they were recovered from a position during the excavation, but then she would just reassign them to bed I sometimes. And this recurs over and over and over again in her excavations. And if you look at the artifacts that were recovered from above the unconformity that she defined, you know, which was the same unconformity that we found a little over a year ago, and what was found beneath it, there aren't really that many differences. You know, you think that the material that came from bed I is all unifacial, but when you really look at it, it's not. They are bifacial artifacts in there. And there's some that look identical to what was found above the unconformity. So what I think's going on is that Irwin Williams probably did not find those. She thought she found those artifacts in bed I, but they were really coming above the unconformity, which undulates quite a bit.
Yeah.
Yes, Irwin Williams, to repeat, never really wavered as to the physical position of the artifacts. She recognized that say, a unifacial artifact was in this part of the section. In 1964, because she was looking at this kind of flow roll contact in here, she had used that as a basis of choosing to name this part I and this part G. But when she found this contact over here in 1966, she decided, no, that was a mistake, that really this and this were all part of bed I. She didn't move the artifacts, she didn't waver on where they came from, she just refined the naming of the unit.
Did an ancient river carve a channel 11 meters deep through the Hueyatlico ash and the beds below it, explaining how the artifacts could have been found where they were? Or did the volcanic ash cover and shroud the man-made artifacts and butchered animal bones sometime over 250,000 years ago? A surprising answer to this dilemma may be found in the single-celled body of one of nature's tiniest creatures. Diatom, any of various minute, unicellular, or colonial algae of the class Basilaриophyceae, having siliceous cell walls consisting of two symmetrical parts. Sam Van Landingham is an environmental geologist from Midland, Texas, whose expertise is using diatoms to date the age of rock strata.
And he can go into a strata, he can take a sample, he can find these little things called diatoms, which are microscopic, and with his 40-some years of experience, he is able to tell which diatom this is, when it existed, and when it didn't.
Some of these diatoms, some of the types that are in here, are still living today. And some of them are not. Some of them died out over 80,000 years ago, and those are the ones that I'm trying to find.
First, we need to know, Sam, what are diatoms?
Diatom is a tiny one-cell microorganism, and it's enclosed in a siliceous or glassy skeleton, and it's highly ornate, and you need one of these microscopes to be able to see them.
An artifact is dropped on the ground near the edge of a stream. The water level rises, surrounding the artifact with living diatoms. When the diatoms die, they sink to the bottom and become part of the sediment. Over time, the sediment builds and covers the artifact. This process is repeated and new beds are formed, each containing unique communities of diatoms. Long after the water has receded, geologists can determine the age of the various strata by analyzing the diatoms which are present.
Sam has dated the layer that we find the artifacts in with diatoms?
To get a good date based on diatoms, a person who studies algae or microorganisms would need to find several of these microorganisms in the sediments.
Okay, so what that means is that in the identification process, you are able to relate that to the age of the sediment that you find them in.
Many of the samples have overlapping ranges, and we can get good dates from them, and very frequently, which is quite unusual. In fact, it's one of the best areas in the entire world to date sediments with diatoms.
Diatoms have an extensive fossil record, going back millions of years and existing in various forms through the present day. Some of these amazing microorganisms have a lifespan of only minutes or hours, yet many of the species have remained unchanged for millions of years. Periodically, whole species will die off, never to be seen again in the geologic record. When those species are found in rock strata, it gives a minimum age for that strata. Deep in the ground at Hueyatlaco, where all the artifacts were found, hundreds of species of extinct diatoms were discovered, including Navicula cryptocephala and Cimbella cistula. According to Dr. Van Landingham, this means the strata is of Sangamonian age, a minimum of 80,000 years old.
The diatoms that I studied at the Hueyatlaco archaeological site are well known to geologists and paleontologists. They died out over at least 80,000 years ago, over 80,000 years ago.
You're saying that the diatoms that you ended up testing were taken from the exact place that the artifacts were found?
Right, that's correct, yeah, no question. That would indicate to me that the artifacts found at the Hueyatlaco archaeological site are over 80,000 years old. Yeah.
The biggest question that needs to be resolved as well is this, the diatom evidence.
Yeah.
Because Sam Van Landingham, who I've never met, has examined the diatom assemblages from, below the unconformity and also above the unconformity. Yeah. And he finds no difference between the diatoms here and the diatoms over here.
Yeah, that's right.
And that does present an issue that needs to be resolved. Yeah. But I remember in the original manuscript, he always talked about that the Sangamon age was a minimum age.
Yeah.
And so if that's the case, then maybe there is no conflict here, because that's where the diatom assemblage, could maybe it's Sangamon or maybe it's older, because that's what a minimum age means. So maybe there is no conflict. But where the conflict would come in would be finding those diatoms in the younger sediments above the unconformity. And I think the thing that needs to be worked out here is see if we can get better geochronological or any geochronological dates, from above the unconformity. And that's, something that needs to be considered over here in the younger deposits. Are there younger diatoms? Are they in the same condition? Are these more degraded and these less degraded? And do they occur in the same frequencies? X percentage of this type diatom and the same percentage over here consistently. Mm-hmm. And those are the kinds of things that I'm not a diatom expert, and I'll have to read the report.
The study of diatoms is a very, very esoteric study within the discipline of geology. Hardly any geologists know about this stuff. Sam's evidence is that there is a family, not just one, but a whole family of diatoms in the inset that are identical to the same family outside of the inset. And we know that both of these families have been extinct for at least 80,000 years and very possibly hundreds of thousands of years. So how is it possible for an inset to be younger than the material right next to it if they contain these same diatoms?
What makes Dr. Van Landingham question the existence of an unconformity is the fact that he found multiple communities of extinct Sangamonian diatoms on both sides of the disputed contact.